Imagine falling. What if, instead of succumbing to gravity, you could fundamentally reshape your own skeleton to defy it? This isn't a thought experiment. It's a biological reality for the paradise tree snake, Chrysoplia paradisi. As it launches itself from a high branch in the Southeast Asian rainforest, it initiates a breathtaking transformation. It doesn't sprout wings. It becomes a single, continuous wing. Its ribs, unbound by a sternum like ours, pivot upwards and outwards, stretching the skin and doubling the body's width. The result is a flattened, concave cross-section, an organic airfoil shaped not by muscular contraction in a fraction of a second. This is not passive falling. It's an active, controlled aerial maneuver from the very first moment. This radical reshaping creates a surprisingly sophisticated aerodynamic surface. As air moves across the snake's body, it must travel a longer path over the curved top than the concave bottom. This is the Bernoulli principle in action. The faster-moving air on top creates a lower pressure zone, while the slower air beneath creates a higher pressure zone. The difference generates lift. Computer models created by researchers have shown this cross-section is so effective that it can generate aerodynamic forces comparable to a scaled-down airplane wing. The snake essentially surfs on a cushion of high-pressure air, turning a vertical plummet into a shallow, controlled glide that can span the length of a football field. Yet any aeronautical engineer will tell you that a long, thin wing is inherently unstable. It should, by all rights, tumble uncontrollably. But the flying snake doesn't tumble. The secret is in its constant serpentine motion. It undulates through the air in a fluid S-curve, a motion that looks deceptively like swimming. But it isn't pushing against the air. This is a masterful act of dynamic stability. Each wave that propagates down its body makes minute adjustments to the airfoil. It's a continuous feedback loop. A slight tilt to the left is instantly corrected by a muscular ripple to the right. This keeps the center of pressure aligned with its center of mass, preventing the catastrophic stalls and spins that would plague a rigid object of the same shape. The snake isn't just a glider. It's an integrated flight system, where the body is both the wing and the control surfaces, constantly recalculating its path through the sky. The evolutionary pathway to this ability is perhaps more remarkable than the flight itself. It's a classic case of exaptation, where a trait evolved for one purpose is co-opted for a completely different function. The muscles and skeletal mobility needed to flatten the body weren't developed for flight. They were likely first used in defensive displays, like a cobra flaring its hood to appear more intimidating. A threat posture became the foundation for an airfoil. And the lateral undulation? That's just how snakes move. The same neuromuscular pathways that propel it across the forest floor are repurposed to maintain stability in the air. Evolution didn't need to invent flight from scratch. It just found a new aerial application for the snake's existing terrestrial toolkit. It saw a slither and imagined a soar. This strange form of locomotion forces us to question our definitions. What is flight? Is it only the powered, flapping motion of birds and bats? Or is it any form of controlled, non-ballistic movement through the air? Flying squirrels use a membrane, the patagium. The flying snake uses its entire torso. One is passive, the other is dynamic and actively controlled. The snake's method is arguably more complex. It represents a unique evolutionary solution to the problem of getting from one tree to another without touching the ground. It blurs the line between gliding and flying, between falling and soaring. The snake demonstrates that the routes to conquering the air are more varied and imaginative than we might assume, proving that sometimes, to fly, you don't need wings at all. You just need to be a better faller. Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.